Hi folks, good afternoon. Sorry I'm a couple minutes late. I was just pulling something up on Canvas that I want to talk about before we get started today. How's everyone doing? It's Thursday.
Good, how are you?
Good, good. I feel like I'm always a little tired at the end of the week, so but at least with summer school, we only have class 4 days a week, which gives us a little bit of time to regather ourselves, rejuvenate ourselves. Okay, so we're gonna start off. I'm gonna share my screen so we can take a look at Canvas. I feel like this week has literally run away from me, and somehow it's Thursday, and I have not provided you with information about your test on Monday, and I really apologize for that. That is not in my normal nature. So I want to show you what I will be putting up on your page. This is actually from my other classes page right now, but what you're going to see for your exam is going to be super similar. And so I just want to talk through that right now so that you can know what to expect, okay? So let me go ahead and share my screen. Whoa. Okay, so okay. So again, I apologize that I have not put this up on your page yet. This is for my other class, but you will have something like this and I will post it later this afternoon, okay? So it says Wednesday, that's not right. On Monday, you're gonna have your first exam. And so these are a few structures that I have found work during this time of test taking in a remote situation, okay? So a few things. You are going to be allowed to have a cheat sheet to use during your exam, okay? This should be a sheet that you create yourself. You can handwrite it, you can type it, that's up to you, but I want it to be something that you make yourself. Okay, you can certainly borrow from other resources, but I think part of the process here is like when you go back over old content, what really stands out to you as things that are important and what should be on that cheat sheet. So this one says a double-sided, yours is going to be a single-sided, okay? So this is a single-sided sheet of paper for you. Between now and Monday morning is when you should be making this reference sheet, okay? You can include formulas or equations, but you can also include examples. So that is totally fine, okay? I know some professors are like, oh, you can only have formulas, and I understand that, but I think for us, I'm opening it up to have examples as well, okay? This is the only resource that you can use on your exam. Or if you're like, I really want to challenge myself and make sure that I can do this without, you don't have to use it. But either way, I want you to create one. You're going to submit this with your exam when you upload things to Canvas when you're done with your exam, okay? So again, aside from the cheat sheet, the exam is not open notes and it's not open resources. If you were caught cheating, you earn a 0 and you forfeit the right to have that final exam be optional. And that's just a non-negotiable, okay? This one again is for my other class, so I said no calculator. You will be allowed to use a calculator on this test, but it's going to be a scientific calculator, not a graphing calculator, okay? So if you have a graphing calculator like this, you may not use that. You may not use Desmos, but you can use a basic scientific calculator. That is fine. Okay, and I'll be clear in your direction so you can see this again on your Canvas page. There will be an extra credit on the exam. And so usually the way I do it is I'll either have an additional question at the end that's extra credit, or I'll say, like choose 3 out of 5 parts to do, and you can do an extra part for additional credit. This is in addition to that classwork that's due on Monday that is in another 5 points. Okay, so you have 2 opportunities for extra credit on this exam. Now, logistics. I like to give students 24 hours to take the exam. that is not because I'm writing a test that should take you 24 hours, okay? I'm not trying to make you work for 24 hours straight. But I understand that especially right now, some of us have non-negotiable work hours, or we have folks that we need to care for, or we just are taking a lot of other classes, okay? So what's gonna happen is on Monday morning, not Monday morning, at Monday at noon, your exam will open, okay? You can take a look at it then, you can save it until that evening, whatever works better for you. But you need to submit your exam on Canvas by noon on Tuesday. So before we meet on Tuesday, you need to have that exam uploaded. The last thing that I ask for is on the cover of your test, I have this statement of integrity. I ask you to hand copy that. So I want to see your handwriting, copy out the full statement of integrity, and then you're going to sign it to tell me that you only used that cheat sheet and no other resources to complete this exam, okay? So those are the 5 parts to this taking an exam that, again, I will modify to fit your class schedule. So it will open at noon on Monday, close at noon on Tuesday. You will have 24 hours with your single-sided cheat sheet as well as a scientific calculator, if you like, to help with some of those calculations. This will be chapters 4 and 5 that are on the test. So same thing that was on your schedule, your original schedule with your professor, but you can also check the schedule on Canvas to show you what sections are going to be on there. Okay, so you are taking this on your own time. You do not need to come to class on Monday, all right? I think we all know you can still cheat even if you're pretending like you're not. Like, I can't see what you're writing or what you're looking at, but my hope is that you are not cheating, because I will tell you, I'm very flexible about a lot of things, but if there's cheating happening, we're not going to have 24 hours. It is going to be a lot more strict about how the test goes. So please take this olive branch of here's a cheat sheet, you have 24 hours, and let's make it a positive experience for everyone, okay? Are there any other questions right now about the exam on Monday?
So do we have class at all on Monday, or is it just the test?
It's just the test.
Okay.
Okay.
Thank you.
Must you have a cheat sheet? You need to make one. You don't have to use it if you don't want to, but I want to see that.
And then you said you need to submit the cheat sheet?
Yes, you need to include that. So your cheat sheet, your statement of integrity, and your exam all get uploaded in a single document.
How many questions will be on the test?
Enough. Usually around like 10 to 15. Note, it is a single-sided sheet of paper. Okay, so single-sided for everyone. If you feel like you have really big handwriting, maybe you can try typing it and shrinking that a little bit, but it has to be a single side. All right, any other questions about the exam? Okay. All right, well, if you think of any between now and Sunday evening, please let me know. But you do not need to show up to lecture on Monday. There will not be lecture on Monday. But if you're working through the test and you have a question, like a clarifying question, you can email me and I will get back to you, okay? If you email me at like 3 a.m. though, I might not get back to you until like a lot later that morning. 8 by 10 is fine, yeah. If you want to use less space, that's fine.
Will the statement of integrity be on something else so that we like can see it and write it on it before the test?
Yeah, so I usually leave space on the cover of the test for you to write it right on there.
Okay, so we have to copy that exact statement? Okay.
Yeah.
So if we make the cheat sheet like digitally and we take pictures, let's say I want to take like a unit circle and put on my cheat sheet, that's fine if I can take outside resource pictures and put it on my cheat sheet as long as I'm the one who made it.
Yes, exactly. Other questions? These are all really good questions. What chapters? 4 and 5. 4 and 5. Okay. One last thing that you will also be getting, and again, I'll do my best to get this out tonight for you, is I give you a list of topics that are going to be on the exam, along with how many points that topic is going to be worth on the exam. You can kind of see in advance like what the weight of different topics might be. Okay. One thing that your professor did tell or share with me is she did say that if you pass every single exam, then that final exam is optional, and I would like to honor that for you. So if you pass every exam, that final exam for you, that last day, is totally optional. You don't have to do it if you don't want to.
For the statement of integrity, if we're like, I don't have a printer, so I'll probably be doing it like writing it digitally. Is that fine? Okay.
Yeah, that's totally fine. So with the exam, here's a few ways that you can do it. You can print it out if you have a printer. Like I don't have a printer, so I wouldn't print it out. You can handwrite it on paper, or you can upload it to a tablet and write it on there and then just turn that in. So lots of different options. I don't judge in terms of technology, so you don't have to go out and like buy a printer or anything. Whatever you use is fine as long as your work is organized. So like don't send me on a scavenger hunt, like you do like 1 and then you do 7 and then you do 10. Like do the questions in order, at least when you submit it, so that so it's a little bit easier for me to grade.
Okay, thank you.
Yep. All of the recordings should be posted. I do it right after class, so it should be in Canvas, all the links. Okay. I know once in a while, sometimes the links don't work or something. If you run into an issue, well, where did you check, Gracie? Where were you looking? Okay, so let's go to your course and let's make sure that we know how to find it. I know that everybody organizes their Canvas shell differently. So I did try and keep everything in modules, right? So if we go to modules, there's not a separate link for videos. Everything is in these pages. So if you want to find the video for 5.2, you click on 5.2. Bam, blank notes, complete notes, and the Zoom class video for that day. Okay, so everything's sorted by topic and not like a separate section for videos. All right, cool. You're welcome. I'm glad you asked. I'm sure there were other people who were like, where are these videos? But yeah, so today we'll be finishing 5.4. So yesterday we started a little bit. So I did the first half of the notes and the lecture video from yesterday. And then today, after we finish, I'll post the complete notes for 5.4 and then the Zoom video for today. Okay? So pass that along in case you have classmates who haven't been making it to lecture, that this is where all the new stuff is, so that they don't feel like there's nothing on Canvas. Okay? All right. Any other questions about Canvas or the exam? All right.
The cheat sheet required?
I want you to make one. If you choose not to use it on your exam, that's up to you.
Okay, thank you.
Okay. All right, so I'm going to stop sharing my Canvas screen and I'm going to go ahead and share my tablet screen so we can pick up where we left off for 5.4. Okay. Okay. So yesterday we finished off by looking at the properties of logarithm, okay? And we played around with some numbers and we noticed some patterns. that if we have two separate logs and we are adding them, then that's equivalent to if we take a single log of those terms multiplied. And then we were able to extend that to subtraction and division. And then we had this power property at the very bottom. And so we went through and we wrote down a few examples with numbers. Okay. And then that's where we left off for class yesterday. And so what we're going to start with today is we're going to go through a few more examples of condensing and expanding, and then we're going to jump back into our solving equation, okay? So in a situation like this, I see that I have 3 different logs. And so because I have 3 different logs, I'm thinking, okay, I want to take these and I want to condense them, meaning I want to write it as a single log. Okay, and again, that skill is going to be something we use a lot when we are solving equations. Okay, so usually the first thing I look for when I'm condensing is, are there any powers? Okay, and actually let me change that. I don't mean powers, I mean coefficients that become powers. So if there are any coefficients, I can move them up to the power, okay? So that's the first property that I look for. And this first log has no coefficient, so I don't need to worry about that. The second one, don't have to worry about that. But the third one, I'm gonna take this 2 and I'm gonna move it up to be a power for 3. And so what I end up with is log of x minus 2 plus log of x plus 5 minus log of 3 squared. Okay. What is the base here, by the way? If I haven't written it, what is the base?
10.
Perfect. That base is 10, right? So when we don't write the log, it is a common, or if we don't write the base, it's a common log, which means that it is a base 10. Okay, so now after I look for coefficients, then I look for any addition, and I'm going to change that to be multiplication. And I can also, at the same time, look for any subtraction and change that to division. So this plus sign means I'm going to condense these into a single log, and they're going to be x minus 2 times x plus 5. So I'm going to get log of x minus 2 times x plus 5 minus log of 3 squared, okay? And now when I want to condense this and this, what am I going to do to those 2 values?
Divide them.
I'm going to divide them, all right? So I'm going to get log of x minus 2 times x plus 5 over, you can write 3 squared, or you could write it as 9, not a triangle, 9. And you could also write this and FOIL out the top, and you'd get x squared minus 2x plus 3x, or plus 5x is plus 3x minus 10. You could have that all over 9. Okay, so this is a fine place to leave it. You've condensed it, meaning at the end, you only have 1 log in your expression, okay? Any questions about this first example? Okay. So, what do we think the directions are going to be here for this one? Condense or expand?
Expand.
Yeah, this is going to be an expand situation, right on, because I have 1 log, and so I'm going to want to unpack it. And when I unpack things, I usually go in the reverse order. So I don't do my coefficients first, but instead I look for any multiplication and I change that to addition. And then I look for any division and I change that to subtraction. Okay, so let's do those first and then we'll deal with the powers. So a good first step might be to say natural log of x to the 5th plus natural log e to the 6th. Okay, so I've taken the multiplication and I've changed it into addition. Minus natural log of y squared, because we're dividing that y squared. And then what do you guys think the sign should be for the natural log of z to the 7th? Plus or minus?
Minus,
Ah, why do you say minus?
because it would be in parentheses, and so the minus sign would take over the positive sign.
Yeah, exactly. So the y squared and the z to the 7th are connected by multiplication. So you're right, it is a plus sign, but then they're both on the bottom. So we need that parentheses there. So some people write out this first step and some people jump straight to here. And I would say that either way is fine. If you trust your arithmetic and your distribution, go ahead and start right there. But if you know you tend to make sign mistakes, maybe just take that extra step to write that out and prevent your own mistakes, okay? All right, so we took care of the multiplication and the division, and so now we're gonna take any powers and we're gonna bring them down as coefficients. And so I'm going to get 5 natural log x plus 6 natural log e minus 2 natural log y minus 7 natural log z. Now, there's actually one more thing that I can do to simplify this. What is that thing?
The natural log and the e,
Yeah, what can I do with that?
they cancel out.
So natural log of e is one of those nice values that we should know. Natural log of e is 1. Okay, and that we learned from one of the properties in 5.3. So really, we can write our final answer as 5 natural log x plus 6 minus 2 ln y minus 7 ln z. And that would be considered our final answer, okay? All right, so we've seen a condense, we've seen an expand. Let's try a few more examples. So, condense or expand?
Condense.
Yeah, we're going to turn this into a single log. All right, so condense, we said a good place to start is coefficients. And that if we have any coefficients, we'll move it up to a power, okay? So this is going to be natural log of x cubed y cubed, because this 3 became a power up here, plus natural log of yz squared to the power of 2, because this 2 comes up to be that power, okay? So when you're condensing, start with those coefficients. We're actually going to take another step here, and we're going to fully distribute that power. So 3 to the x cubed and the y, and the 2 to the y and the z. What's the new power of x now?
9.
X to the 9th, good, and y to the 3rd. plus ln of y squared z to the 4th, right? And then you're going to check for any addition, which is going to become multiplication, and any subtraction, and it's going to go to division. And so we'll get an almost final answer of natural log of x to the 9th, y to the 3rd, y squared, z to the 4th. And we want to make sure that we combine our like terms. So what's the power of y going to be?
5.
Yeah, y to the 3 plus 2, or 5. All right, so that gives us a final answer here of natural log x to the 9th, y to the 5th, z to the 4th, okay? All right. Condense or expand?
Expand.
Expand, all right. So I'll give you folks a couple minutes to work on this. But remember, in this case, we don't start with our powers. We actually look for the multiplication becomes addition, and our division becomes subtraction, okay? So see how you can get started with this one, and then I'm happy to answer any questions. Okay, I hope we were able to get this as a first step here, right? We know that that 6th root of x to the 5th is going to be subtracting the x to the 9, the log base 9 of y cubed. And then remember, we could say in parentheses plus this log of 7 of z minus 2 to the 7th, or we could just distribute that minus sign right away. And then just have log base 9 of z minus 2 to the 7th. Okay. I tend to do this method where it's basically like if it's on the top, then it has a plus sign, and anything in the denominator has a minus sign. And then I don't need to worry as much about distributing any sign. All right, so we've taken care of the multiplication and the division, and now we're looking to take the powers and bringing it down as a coefficient. So I think the last two are really easy because we can do 3 log base 9 of y minus 7 log base 9 of z minus 2. But what do we do with that first term? Any ideas?
Turn it into 1/6.
Okay.
And then subtract from 5.
Okay. So this right here, actually, okay. This, I'm going to write over off to the side. When I have the 6th root of x to the 5th, that is equivalent to x to the power of 5/6. Okay. So if you were to generalize that, you have something raised to a power, and then there's a root on the outside. you can always write that as x to the power over the root, okay? And believe it or not, this random skill right here comes up so much in calculus. Calc 1, Calc 2, Calc 3, being able to go back and forth between these two, between a radical and the rational exponent is super, super important, okay? So I love what you said that we're gonna have the power, the 1/6, and in fact, we can actually write this as x to the 5/6. So then our coefficient is gonna become 5/6 log base 9 of x, okay? All right, any questions on this one? Okay. All right, so it looks like we've got 2 more here. Let's walk through these. So in this case, I see more than 1 log. So I'm going to want to condense them into a single log. So let's move all those coefficients up. We've got natural log x to the 1/2 minus natural log y to the 8th minus natural log z to the 5th. All right. That's going to give me natural log with x to the 1/2 in the numerator. And in the denominator is going to be both the y to the 8th and the z to the 5th. Okay, because they're both being subtracted, which means that they're both in the denominator. And one last thing, if I wanted to write x to the 1/2 as a radical, what would that be?
Root x.
Yeah, it's gonna be the square root of x, exactly, okay? So again, this being able to go between x to the 1/2 and the square root of x, that comes up so much in calculus. So that's really why I wanna like emphasize what do we do with these fractional exponents, okay? And let's take a look at one more expanding situation, okay? And so I have to unpack any multiplication and division first. Log base 8 of square root of x minus log base 8 of 64 minus log base 8 of y cubed. All right, coefficient for this term.
Would it be x to the 1/2?
Yeah, we're gonna bring that 1/2 right down to the front, perfect. Minus log base 8 of 64. That question is really asking you 8 to what power equals 64?
2.
2, so I can replace this with a 2. And then I'm gonna bring that power of 3 down, so 3 log base 8 of y. And that would be a fully expanded log. Okay. All right, so the condensing is super important for equation solving. The expanding is going to be important because we always like to know if we can do something, how do we undo it? Okay, so that's really why we learn the expanding part. But I have a summary here for the log properties, all right? So we've got our product, our quotient, our power rule. And this change of base one is, oh gosh, this change of base one is the one where it helps you type into your calculator. right? So if you remember very early yesterday, I was like, oh, type in log of this divided by log of that. That's the change of base rule, okay? And that's really what allows us to evaluate something on our calculator. And so you have this summary. This might not be a bad thing to put on that cheat sheet, right? Or on that reference sheet, just having a list of those properties. But if you're someone who does really well with examples, you might want to write down 1, maybe 2 examples, depending on how much room you have, okay?
Excuse me.
Yes.
I have a question with that last example. Yes.
Yeah. Okay.
Why did we wrote 64 y to the power 3 log base 8 64 minus log 8 y 3? Shouldn't
Because,
be.
yeah, but it's minus 2 things that are added together.
Oh, so you just apply the
Yeah.
negative.
Mm-hmm.
Okay.
Mm-hmm.
Thank
Good
you.
question. Okay, so let's see how these apply to our equations, okay? So yesterday I asked you to copy down these steps and I said, step 1 is blank, but we're gonna come back to it. So here's step 1. Step 1 is you are gonna condense the logs into a single log, okay? In all the questions we saw before, except for that last one, we could do it because they only had 1 log. But now we're going to go back and see how can we solve a question that has more than 1 log, okay? All the other steps are the same. It's just that one additional part where we have to take a bunch of logs, condense it, isolate, and then rewrite in exponential form and solve for x, okay? So 1 added layer. So let's go back to this example, okay? Let's take this left-hand side and condense it into a single log. Right? Any addition becomes multiplication. And before we do our next step, let's go ahead and distribute that x in there. So we get log base 8 of x squared minus 12x equals 2. Okay. I've condensed my log into a single log. And I've isolated my log. It's already isolated. So my next step is to write it in exponential form. So if we write it in exponential form, what do we get?
Would it be 8 to the x squared minus 12x equals 2?
It would not be, actually. So let's maybe go back up here, right? Where do all the things go? I agree that 8 is our base, but what power is it raised to?
To the second power?
To the 6th power?
No, to the second power.
The second power, I'm so sorry, yes. So you're always taking the base and you're raising it to whatever number is on the other side, okay? The whole point of this exponential form is to get that power, or get the thing that's logged out of the log. And we don't want it in the power either, so that's why it goes on the other side. All right, so you're right, we're gonna get 8 to the power of 2 equals x squared minus 12x. And 8 squared is 64, so we get 64 equals x squared minus 12x. Now, this next phrase that I'm about to tell you is something that you should take with you through every single math class that you ever take, okay? Which is when you see a quadratic like I see this x squared, the process I want to think about is this. Move everything to one side, set it equal to 0, and factor. Okay? Let me say that one more time. You're going to move everything to one side, set it equal to 0, and factor. So I'm going to get x squared minus 12x minus 64 equals 0. And we want to know how to factor, all right? So when we factor this, we get x and x, right? That's how we make x squared. But I need a pair of numbers that multiply to make 84 or 64, excuse me, but also add or subtract to make negative 12.
16 and 4.
16 and 4. All right, so 16 times 4 is 64. Now, which one of those needs to be negative?
The 16.
The 16, good. Because we're trying to make negative 12. So negative 16x plus 4x is going to give me negative 12. Okay? And so this is going to give me x minus 16 equals 0 and x plus 4 equals 0, or x equals 16 and x equals negative 4. Okay? Now, before you go ahead and box off both answers, we need to check our answers, okay? So I'm going to plug 16 in. I would get log base 8 of 16 plus log base 8 of 4 equals 2, okay? And so let's see, if I type this into the calculator, how do I type log base 8 of 16?
16 log, and then in parentheses 8.
Nope, the 16 is not a power. The 16 is the thing being logged.
Log 16 over log 8.
Yeah, we want to use a change of base here. So log 16 over log 8. And we would change the second one by doing log 4 over log 8. And so go ahead and type that into your calculator and see if you get 2 when you add those together. And I believe this should work out, right? We get, let's see what we get. Log 16 divided by log 8 is 4/3 plus log 4 divided by log 8 is 2/3. And so that's going to give me 6/3 or 2. Okay? So when I check my answer for 16, that works out. So I can go ahead and box 16 because I know that's an answer. But we're going to try the same thing with the negative 4. And so we're going to have log base 8 of negative 4 plus log base 8 of negative 16 equals 2. And so to type this first one in the calculator, I would do log of negative 4 divided by log 8. And to do the other one, I get log negative 16 over log 8 and hope that that equals 2. All right? So let's type that in, log negative 4 divided by log 8. And what are we getting?
I got a domain error.
You got a domain error. Anybody else get a domain error?
Yeah.
Okay. So here's what happens. Turns out that both of these are going to give you a domain error. All right, which means that x equals -4 is not a solution. And in fact, it is an extraneous solution, okay? But here's why that is. And let's think back to the graph of logs, okay? So the graph of a log looks like this, okay? And so remember, we said that it has a restricted, not range, but restricted domain. So if I wanted to find log of -4, I'm really saying I want to point over here. But is that point on the blue curve? And the answer is no. And same thing, if I try and find log of -16, that's like way out here. It's not on the blue curve. That's why we get a domain error. Okay? So up until now, we've been checking our answers, and I've just told you, like, believe me, this is important. So we're finally here at the moment where we can see why it's important, because sometimes the answers work, and that is our solution, and sometimes the answers don't work, and that is not a solution, okay? All right. Let's give example.
For the last example,
Yes, sorry, what's up?
is there, when you were checking, is there a reason that you did the dividing thing with the logs rather than just making it log base 8 of 64?
So some of the newer calculators can handle a different base, but a lot of the old school calculators, including the TIs, they don't allow you to have a base other than 10 or E. So that's why we have to type it into like a calculator friendly sort of situation. But if your calculator allows you to type in the bases, then you don't need to do that step.
Okay, I was just thinking, because like at that point you could kind of just do it in your head, because 8 squared equals 64, but I don't know.
Where are you seeing 8 and the 64?
If you changed it into log base 8 of 64 equals 2,
Ah,
and
okay.
you could just,
You could, but then this would also give you log base 8 of 64. Okay.
okay.
So the catch
you.
there is if you are logging something that is negative, you can't put negative numbers into the log. Does that make sense?
Yeah.
Okay. All right. Any other questions on example 4? Okay. Well, let's talk through example 5. All right. So what do we want to do here before we get started with like solving?
Move the logs to one side.
You could move the logs to one side. Yeah. You could do that and we get log of x minus 2 plus log of x plus 5 equals, or no, minus 2 log 3 equals 0. Yeah, all right. What's the next step here, folks?
Condense.
Mm-hmm. All right, what do we want to do first in our condensing process?
We would want to change the minuses and pluses into multiplication division.
Before we do that, it might be better to look for any coefficient, okay? So like when I'm thinking about it, I'm like, oh, condense starts with a C, coefficients starts with a C. So like this 2, let's bump that up here first, all right? So let's make it log of 9, and then let's do what you said where we turn it into multiplication and division. All right. What's it look like if we turn all the pluses and minuses into multiplication and division?
X minus 2 times x plus 5
Mm-hmm.
divided by 9.
Perfect. And we actually saw this earlier, right? We did this same part just without the equation part. And so if we go ahead and we got x squared plus 3x minus 10 over 9 equals 0. And when we first did just like the condensing part, I said, what's the base? And you guys were right, it's a 10. But the 10 is important now because when we rewrite it in exponential form, we need to make sure that we have the base raised to the number on the other side equals the thing that we are logging. Okay? So this is a good example of when I tend to write the 10 in because it helps me figure out what numbers to put where in the next step. Okay. 10 to the 0 power gives us 1. I'm going to go ahead and multiply the 9 to the other side. And now, what might be our next step?
Get everything to one side.
Good, very nice. So we've got x squared plus 3x minus 19, okay? Now, in this case, this is not factorable, right? There's not a pair of whole numbers that multiply to make 19 and add or subtract to make 3. So if we cannot factor something, what's an alternate method?
The quadratic formula.
Quadratic formula, good. So let's list out, we've got a equals 1, b equals 3, c equals negative 19. And if we put that into the quadratic formula, we get negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times negative 19, all over 2. And that gives us negative 3 plus or minus, let's see, 9 plus 4 times 19 gives me square root of 85 over 2. Now, for the sake of this problem, because I want us to check our answers, let's turn this into the 2 decimals that are equivalent to that. So we're going to do minus 3 plus the square root of 85, and then divided by 2. That should give us 3.110. And then negative 3 minus the square root of 85 divided by 2, which should give me negative 6.110. Okay?
Sorry, I don't, is that 4.1 or 41 times 79?
4
And the-
times
and-
4 times 1 times
Okay.
negative 19. Yeah, sorry,
Okay.
let me go over that a little bit. Times.
Thank you.
You're welcome. There we go. That should be a little bit more clear, yeah? Okay. So I bet you guys can tell which one of these is going to cause the problem when we try and check our answer.
positive one because we cannot plug negative numbers into a log.
Right, so this negative is going to make this whole thing negative, and the thing we cannot have is you cannot have log of a negative number. Okay, so that is the thing that gives us the domain error. So I'll leave you to check this on your own time, but this one is not a solution, whereas this one should be a solution. Okay. All right, any questions about number 5? All right. Let's try one more over here, okay? So I'll give you a minute or so to get started. Think about how you want to approach this. It might be slightly different than how someone else chooses to approach it, and that's okay, okay? So take some time, figure out how you want to condense these so that you can get a single log, and then how can you rewrite it in exponential form. All right, who's got a first step for us here? A potential first step.
You would subtract log for parentheses 2x plus 1 by log for x plus 2 in dividing it to divide log for x plus 2 over 2x plus 1.
Yeah, you could definitely subtract those, okay? Anybody else have any other ideas? How else can we start to solve this problem?
For the right-hand side, you can write log base 4 x plus 2 over 3.
Yeah, okay.
Then the base is the same, so 2x plus 1 is going to be equal x plus 2 over 3.
Yeah, okay. So here's one thing that I really want us to avoid. I know you can type this into the calculator and get a number. Oops, not sharing right now, hold on. Okay, so this log base 4 of 3, I know you can turn that into a number. I do not want you to turn it into a number, okay? So just because something can be turned into a number doesn't mean that that's going to give you the most exact answer. So last time we showed how you could move all the logs to one side and solve that way. You can definitely do that here, but just to show folks a different method, we could take this side and condense it into a log, just like you said, okay? So we get log base 4 of 2x plus 1 equals log base 4 of x plus 2 divided by 3, right? Because that minus sign made it a division. And now this actually looks like one of the very first examples we looked at yesterday. Log base 4 on both sides. We can get rid of them. And then we can write it as 2x plus 1 equals x plus 2 over 3. Okay? So there's definitely a lot of different methods out there. And sometimes when we're learning new things, we like pick one way and that's all we know how to do. And it might serve us well in the immediate, but sometimes that can prohibit you from solving different kinds of problems in the future, okay? So that's why I kind of want to showcase some different methods and not use the same one every single time. Now, as far as solving this equation, one of the things that I really don't like working with is fractions. And so I try and get rid of fractions anytime I can. So this 3 in the bottom, I'm just going to multiply both sides by 3 so I can get rid of the fraction. Okay, so I'm going to get 6x plus 3 equals x plus 2. And now this is a super straightforward linear equation that I know you guys can solve. We're going to subtract x. We're going to subtract 3. We'll get 5x equals -1, or x equals -1/5. Okay. Now, do we think this is going to be a problem if we plug it back in?
Yes,
Why?
because it's negative.
Okay. So here's what I really want us to know. The thing that is being logged, like the entire thing, has to be negative. So if I had log base 4 of -1/5 plus 2, right? Like I just plugged in that -1/5. -5 plus 2 is a positive number. In fact, it's going to be 9/5. So that's actually going to be okay. The thing that can't be negative is like the entire thing that's being logged. All right? But we want to check this one too and see if I plug in -1/5, will the thing in parentheses be negative? And this will give us log base 4 of 3/5, which is also positive. So it's actually okay. All right. So it's not that we want to say no negative x values. It's like, does it make the thing in parentheses negative? That's the problem. Okay. Otherwise, in this case, if it ends up being a positive thing inside the parentheses, then we're actually still good to go. All right. So folks, that's it for this 5.4 section. So we do have one more section to cover, but we're going to pause here. We're going to take a 5-minute break. So we'll be back at like 1:11, and then we'll pick up with 5.5. Okay.